Hi guys, I know you're planning to pursue your master's through the Futurense US pathway at the prestigious Rochester Institute of Technology, RIT. I know you have a lot of questions about what really happens in that university, how does the curriculum work, how are the professors, how is the campus life, and most important, what about placements, what is the placement track record of that university? Well, I have been talking to the experts, the people who are representing that university in varied forums to try and understand what does it mean for you, how does your life look like when you study in that university, what happens during your study and post once you complete your masters, what about the job prospects. If you're interested to know about these things, definitely watch the full video where these guys are talking about from their viewpoint why is this an exciting opportunity for you, and I am asking them questions that you guys have emailed it to us about specific nuances about how can you pursue your masters from your dream university, how can you land admission there, and what happens to you post you finish your masters in your dream US university. Hi guys, welcome to this very exclusive opportunity with the top minds from RIT, Rochester Institute of Technology, their College of Engineering Technology. Today they're here and to talk us about the program, about this opportunity, about what is life on campus, what is life after this program, how does the placement work, and many more questions. So I think let's just hold ourselves tight and give it over to them. Over to you guys. Thank you.
Hello, everyone. My name is Mike Eastman, and I'm the Senior Associate Dean in the College of Engineering Technology. I would just like to take a moment to give you a little bit of background about our programs, and then I'll turn it over to the experts in each of the individual programs to talk about their specific areas. Next slide, please, Jake. So one of the things you will experience at RIT is we have unique and non-traditional programs. And what I mean by non-traditional is that our learning experiences are going to blend theory and application in a way that really helps you learn and prepares you for a great career in an industry of your choice. So we're integrating STEM principles and blending theory and application in a way that is unique and different from many other universities. We are emphasizing the skills that you develop, not only the technical skills, but what we call the soft skills or the professional skills for the engineering workplace. Next slide, please, Jake. So what are the things that make us unique? We are really geared towards those students who want to move from their bachelor's degree through a strong master's degree program into the work environment. If you're a student who's interested in going on and getting a PhD, we have thesis options to prepare you for that as well. But the majority of our students are looking to advance themselves in industry. Our philosophy of learning is very much applied and hands-on. Our students learn by doing. While we have a strong theoretical component, the majority of the work we do is going to be rolling up our sleeves, working, learning, making mistakes, learning from those mistakes, and building our confidence and our expertise. Applied problem solving is at the heart of what we do. And one of the strengths of our faculty is that while we not only have research experience, we have faculty with outstanding industrial experience. They've worked as engineers. They know what it takes to be successful in the engineering environment, and they're going to help you achieve that as well. The cornerstone of an RIT education is our co-op experience. All of our programs on the graduate side enable students to participate in co-op, and you will be able to work in industry and learn in addition to what you learn in the classroom. Next slide, please, Jake. So some of the unique things about RIT and what you'll experience here are laboratories. You will find that our educational laboratories are second to none. You will have the opportunity to work on things, to reinforce the theory that you learn in classrooms, and to challenge yourself in ways that you just can't do in universities that don't have the lab equipment and the lab spaces that we have. If you are interested in research, we have outstanding applied research opportunities with our faculty. Many of those opportunities are tied to industry. I encourage you to look at the faculty in the majors that you are interested in, look at what they're doing for research, and find out what aligns with your interests and your desires. We're going to blend theory and practice, and we are preparing you again to succeed in the professional workplace. You will have a lot of team-based project work in this program, and again, the cooperative education opportunities. Next slide, Jake. So cooperative education, one of the things you're going to find at RIT is our infrastructure for co-op is second to none. So when it is time for you to look for that co-op experience, we have our own internal, what is essentially an Indeed or monster.com, where you can apply to companies online. You have a support structure here at RIT. You'll have an advisor from the Career Services Office to help you find those co-op experiences. The co-op experiences pay a great salary while you're working. You're not paying tuition while you're on co-op, and that will augment your education. Because of that co-op, we have exceptional outcome rates, and you're going to find that many of our students end up working for the companies for whom they've co-opted because they've built that relationship and that the companies already know our students. Next slide, please, Jake. So now what I'm going to do is I'm going to turn it over to the next speaker, Jen Schneider, and Jen is going to talk about our environmental health and safety management program. Jen, take it away.
Okay, I had to get myself off of mute. Hi, everyone. You'll notice in that quick slide it says Joe Rosenbeck. Joe Rosenbeck is actually the coordinator of this master's program, and I'm pitch hitting for him today. I've been a faculty within the program for 27 years, and unfortunately, Joe is a little ill today, so I told him I would manage this for you. So let's start. What is environmental health and safety management? Well, you can see the link on that slide there that has some definitions for you. But what I really want to focus on here is that EHS management is a little bit environmental, a little bit health, a little bit safety. Well, what's that means? It means technical understanding, engineering underpinnings with, knitting together with leadership principles. So EHS managers really are the risk manager, the ethics and improvement manager within a technical organization. And we have folks that have done everything from go to work for universities all the way to major Fortune 50 industry, and then also all the way into governmental positions. And this profession is really growing quickly, as you might expect, with issues around waste, fires, wildfires, with issues around risk from climate change. There's lots of opportunity. Can you move to the next slide, please? Okay, so what's unique about us is every single one of us that teaches within this program was out in industry first. Our minimum amount of experience is about 10 years, and some of us have decades of experience in environmental health and safety management and sustainability. We know how it works. So this real world perspective is a big part of what we teach. We also have enormous connections, and I'll show you where some of our alumni have ended up. So can you move forward, please? Okay, so what we're really aiming at here is to make you a technical and leader resource for your organization. We teach you how to systematically reduce risk, reduce impact, and create positive change across environmental health and safety risks. So let's move forward, please. Okay, there's a couple of slides of advisory board members. These are just a few folks that we coordinate with as we keep updating this program. You'll see folks from everywhere from the finance and banking sector. So what are we going to invest in that is sustainability related, all the way through many of our technical and manufacturing organizations. Can you move forward, please, again? And here, what I'd really like to show you is we have some folks that are in some pretty high places, 10 years out from graduating from RIT. For example, the Deputy Assistant Secretary for OSHA. So that is the agency that manages all health and safety in the U.S. government services and private employers, is our alumni from this program, Jim Frederick. In addition to Jim, we also have folks that are the Vice President for Risk and Environmental Health and Safety at Bristol Myers Squibb, at Lawrence Livermore for Disney Corporation, and my personal favorite for the folks that make Tootsie Rolls, which is a major candy here in the United States. Go ahead, you can move forward. So curriculum has some core courses and some electives. So I'd like to point out that you'll see here a lot of courses that are related to management systems design, because risks don't exist in a vacuum. If you have something that creates a risk or an impact, it can move its way through an entire system. So we teach you systems thinking so that you know how to control that risk. And then we teach you how to manage that risk going forward with auditing and integration of EHS management. You'll also see that you have some opportunity to pick some professional electives. Perhaps you're more interested in the environment. You can go in that direction. Or maybe you're more interested in sustainability. You can go in that direction. Or health and safety, for example. Please move forward again. So these electives, as I said, really are a broad range of directions in which you can choose to go, from improvement of systems all the way to technical capacity. Go ahead. Okay, so what we require is a 3.0 GPA or equivalent and some science background. As you might imagine, we need to have some of that science background to be able to teach you the technological portion of this role. It's great if you have some environmental health and safety background through work experience or courses. I will tell you, though, if you do not, but you can show some real interest and aptitude, we tend to allow people to take a chance on it. And if you don't have that background, we will give you some bridge courses to get you ready for our master's program. Go ahead. I want to emphasize that we work on real-world paid work experience through that co-op program that Professor Eastman talked about a couple of minutes ago. We have very deep networks to connect with future employers. In fact, our employers really run the gamut across the world, and we've been able to place students in many, many opportunities that are varied, from federal government to industry, healthcare, consulting, non-governmental organizations, and so forth. Most of our international students, most of our international students will complete several blocks of co-op to be able to get them ready to move directly into that professional career. Go ahead. You can see we have a great placement rate. Quite frankly, we need to graduate more students than we do. We've got more employers that are looking for our students than alumni that we actually graduate every year. We could get much bigger in size. We have a huge LinkedIn network, both our alumni and friends of our programs. And it's through that network that we generate even more opportunities. Go ahead. Okay, so I'd like to emphasize that Joe Rosenbeck has said that he's happy to talk to anyone subsequent to watching this webinar, even though he wasn't able to make it today, and we'll make sure that his contact information is available. Thank you, everyone.
Jan, thank you so much. So now I believe we're going to turn it over to Changfeng Ge to talk about the packaging science program. Changfeng, I think you're going to share your own slides, so you are up.
Can you see my screen?
We can, yes.
Okay.
Well, you're not sharing a screen. We're seeing your name.
Okay. I was disabled. Can you maybe let me to share the screen? I was disabled to share the screen.
Pratiksha, he's not allowed to share his screen. Could you help him share his screen? 1 second. Pratiksha, could you allow him to share his screen?
Sure, Raghav.
Yeah, I was not disabled. Uh,
Done,
I
Raghav.
think
now,
share now.
yes. Yeah.
Very good.
Yeah. All right. Good morning, good evening, everyone. My name is Changfeng Ge. I'm a graduate chair for packaging science. Maybe I just want to explain what's the packaging science. And the packaging science at IIT, we do design a lot of packages, including the primary packaging, transport packaging. We also develop some products in around with the packagings. And we evaluate all the packaging materials and improve the branding. That's all the packaging science doing. These are some examples. We are doing some packaging design. On your left side, you can see this was students' work using those Illustrator, AutoCAD, and SolidWorks to design different packages, display packages, and put it in the shelf and see what's the rendering effect. We also do a lot of evaluation. For example, you can see that some braid, we are packaging some braid. We do a lot of testing on the products itself. And on your right side, you can see the transport packaging testing lab and materials lab here. Usually the packaging involve a lot in production, auto storage and distribution, and even after sales. So these are what's the packaging science doing. This again is some examples. In our packaging science program, we teach a lot of software program, which is on your left side, there's CAPE, which is optimize all those packaging in the container on the pallet. We also teach SolidWorks, which is a really important software to design all the 3D modeling and the rendering part. And we integrate those modeling into the AutoCAD, and this is the design from AutoCAD. So a lot of software skill-based are taught at IIT. I think when we do the co-op, when Professor Eastman mentioned that the co-ops are strengths, a lot of employees just put the SolidWorks, AutoCAD, and other required skills. I think that's put us in a very good position. This is the materials lab we're doing. That's actually, I'm a director of the APC lab. We have fairly sophisticated blown film line, which is 3 co-extruded, and we do a lot of research and development for barrier properties and antimicrobial film with all the films. So this is a very sophisticated lab. Initially, we got National Science Foundation $500,000, and subsequently we got a lot of research gift from the local companies. So these are some development work our faculty is doing. This some research work done by our faculty, Carlos Diaz. He's doing a lot of sustainable packaging. He just got a very big grant from New York State. Do a lot of sustainable packaging materials and using agricultural waste. You saw this picture before. That's our dynamics lab. We call the Enterprise Center. We do a lot of testing, evaluation for all the companies. And we have revenue around 250 to 300,000 per year for doing all this work. And not only for the revenue, but also we connect us with all the industrials if they have some issues in the production line or packaging, so we can always go there to help them. So these are some examples where we do a lot of research with the company, and these examples I'm doing here with my student Akash. We do a lot of measurement and of distribution environment, and we got all the data and we translate it into our lab to simulate actual vibration and shock. So we got a lot of research grant from this area. This is our team. We have, in addition to our faculty, we also have alumni support here, and also a lot of cooperation research relationship. So in addition to those students, we support our students, we also have a very unique co-op for our packaging. I think we packaging science probably is the only program at RIT. We have our own career fair in addition to the university career fair. So that's we have around 28 to 30 companies every year come to RIT just for the packaging, looking for packaging students as a co-op student here. These are some core courses when the students coming for packaging science. For the first year, we do a lot of research method, packaging in the environment, and then some distribution system and packaging for end user. These are the core courses we teach for our students here. We also have a lot of elective courses. The software I just mentioned, they categorize as the elective courses like SolidWorks, AutoCAD. But we also have a lot of practice-oriented courses like Six Sigma, and these are the very useful courses. A lot of our students graduated from our courses and got the yellow belt for the Six Sigma certificate here. These are our co-op and also full-time employee. In the past, Unilever was the biggest employer in co-op, and over the time, the medical device company started to take over now. And we recently, last few years, we got a lot of Tesla co-op, and for the graduate student, we have around 10, 12 students now working full-time at Tesla just from packaging RIT. So this, so you can, over the years, you can see the evolution of the who was taking over the leading employee for our packaging students here. I just mentioned that we have a career fair just for packaging here, which is in the winter. As next February is our next packaging career fair. I think that's really put us in very good position. Almost all our students got co-op, including graduate student, undergraduate student. I think that's all. I think we packaging science recently merged with the printing and graphic medium, and we are still small department at a bigger school, but we really have a unique program that's really have a very good reputation nationwide and in the worldwide here. I'm happy to answer any question after the presentation here.
Great, Changfeng, thank you so much. So, and I know you do have to leave perhaps before the end of this. There is one question in the Q&A section, and it's at, is that Six Sigma green belt certificate? And I think you said a yellow belt certificate, correct?
Yes, when we have the course complete, we got the yellow, and the green belt, you have to work with a project with the companies. Yes, you can do it, definitely. But when you complete the course, you automatically have the yellow belt, but the green belt, you still have to working on the green belt on a project.
Great, thank you, Changfeng.
Yeah.
So now we're going to go ahead and turn the mic over to Martin Anselm. Martin, you are up. Jake, you can start sharing Martin's slides.
Hello, everyone. I'm excited to be able to give this presentation about our program. Our program is the Manufacturing and Mechanical Systems Integration Masters. It's within the Mechanical Engineering Technologies department here at RIT. And similar to the other presentations that were given, we have very high placement rates for our graduates, great starting salaries. And because this is more of a mechanical and manufacturing type of degree, the types of job titles that you get would be things you would expect a mechanical engineer to achieve. So quality engineer, operations test engineer, mechanical engineer. So those are types of jobs that you can get when you leave here. The admission requirements is a bachelor's degree in the field of engineering or engineering technology. And we even accept students with computing backgrounds, and you'll see why. but there may be some bridge course requirements depending on your background. We also have a 3.0 GPA requirement, and the exit requirements in part are doing either a thesis or a capstone project and maintaining a 3.0 GPA in your graduate courses, which is equivalent to 33 credits. So in our program, the MMSI program, we have 6 different concentrations or options that you can focus your interests in. Think of these as like a specialization that you want to have in your educational experience and will help you find certain types of jobs. So those are advanced mechanics, electronics packaging, polymer engineering technology, product design, robotics and advanced manufacturing systems and quality. And we have professors that have specializations in all of these different areas, and you can do research in any one of these categories. And really the program, because we have all these different concentrations, you can really customize it. You can take some electives and some other areas while still focusing in one. Go ahead. So I had a slide earlier on job titles. Here shown again, we have very high placement rate. And here's some examples of some of the companies that our students go to after graduating here. Similar to what was said before, our program also has a co-op program. So our graduate students can go off and work at some of these companies, and hopefully that'll be turned into a full-time position. It's not required. But it is often chosen because we have such an incredible network here at RIT with all these different types of companies. We have job fairs. It isn't too difficult actually to find a co-op once you've come and taken a few classes here at RIT. Next slide. So let's look at the curriculum in a little bit more detail. So this is hard to read. There's a lot going on here, but this is just a graphical representation of our program. In orange, there are 5 core classes that are required for every student in our program. And then we have a graduate seminar that we teach. It's a 0-credit course. You take it in your very first term here at RIT. And it's really used as a network opportunity for you to meet professors in our department that are doing research in all these different option categories. So I'm the graduate director. I'm sort of your networking specialist to try to find a connection between you and one of the research areas within our department. And that seminar is really a lot of fun. You learn about all the different types of interesting research that gets done here at RIT. And I have a slide or 2 on what our department does its research on. Then in the light blue boxes are 3 courses that you have to take in one of those options on the right. Some of them have quite a few courses, some have just a few. 3, quality only has 3, so you'd have to take those 3. And then following those 3, you have to take either 1 or 2 electives. So on the right, you can take anything you want. Anything, if you want to add more classes in a particular option, you can do that. If you want to diversify your background, you can go and take classes in other areas. As was mentioned earlier by Professor Schneider, we have professors that have had lots of industry experience, and they bring their industry experience into all these different types of classes. If you're doing thesis, you're going to be taking a thesis planning course plus a thesis itself. So 6 credits of thesis, essentially. If you're doing capstone, you'll only be taking 1 capstone class, which provides you the opportunity to take a second elective. So this is just another way of showing how it adds up to 33 credits, right? We have the graduate seminar and this design of experiments course. Then we have a series of core courses. There are 3 option classes that total 9 credits, and then electives and some exit strategy. So admission requirements, I actually took this right from the website on the bottom there in terms of what term you're admitting to. A letter of recommendation is required. A GRE is required for individuals with degrees from international universities. There is no minimum score required, but we just expect you to take the class. We don't require portfolio, and then there's English language scores that we look for as well. I mentioned the degree program requirement. An official transcript is required for the application, your GPA, submit a one-page personal statement of educational objectives, submit a resume, and then one letter of recommendation. So you do all that within our graduate application website. You upload all those files, and then it will be reviewed. Let's talk about research a little bit, so you have an understanding of what we're actually doing. Our research objectives is really to aid faculty members. You as a student come here to RIT and support our faculty in the areas of research that they're doing for their own industry collaborations or federal collaboration, wherever they're getting their money from and writing their papers towards. The first thing you need to do after you find a professor is to develop a proposal on what your research is going to be, and you actually present that to a committee, which would consist of your research advisor, the grad director, which would be, and an external professor as well. Sometimes that can actually be an industry collaborator, so it could be anyone external that isn't intimately involved with the research necessarily and is reviewing your proposal. Once that proposal is completed, you would go off and do your research. Once your research is done, or as you're getting close to finishing your research, you're writing your report and then preparing a presentation where you do an oral defense at the end of your research. We do have, and I might have a slide on this in a moment, the opportunity to do this capstone type of project while on co-op. So if you're working at a company, you have the opportunity to do that while you're working at the company as well. And a lot of our students opt to do that because they're already working on projects at a company. You may as well use that for your capstone requirement. So when should you be looking for a capstone or thesis project? Really, when you're taking that seminar class with me right in the beginning of your time here at RIT, you're already meeting professors, you're thinking about what you want to work on. So as soon as you possibly can, you would find someone to do your research with and then start preparing that proposal. We tell our students at least 3 semesters before graduating the program, you should have found a faculty member and develop that proposal presentation. And then 2 semesters before you complete, you'll be working on that project and then giving your final presentation just before you graduate. There is a course sequence there shown in the upper right-hand side, but we would help you with that when you're here. There's a lot of support for our students to make sure that you're checking all the boxes and you're actually progressing through the program in a timely manner. Go to the next slide. What's the difference between capstone versus thesis? I get this question a lot. If you're a student who's interested in maybe even higher degrees, looking to maybe do a PhD, then we would probably recommend that you do a thesis option. Other universities, RIT has our own PhD programs that you could apply for. They're usually looking for more of a thesis prepared student. And a thesis is really maybe a higher level of effort with a greater depth of engineering and science knowledge. There may not be a clear result, right? You're doing research sort of iteratively to learn a little bit more about a particular topic, but you need to be able to present what it is that you were able to achieve. And I know this is a minor thing, but the literature review would be expected to be much more in-depth. You'd have to really understand the topic that you're doing your research on. It's not just a project, it's really an in-depth scientific study. Next slide. Here's some examples. We have professors who are specialists in CAD and computer-aided design and other technologies. So we have fluid dynamics research that can be done. We had one professor that was looking at the mode shapes of a lens for a telescope in space. We have professors that do polymer research, and this graphic is actually indicating that in the lower left-hand corner of the polymer slide, there's mechanical testing, there's production, there's materials testing, and there's even the manufacturing process, and even development, like wet chemistry, developing new plastics and things of that nature. Lower right, we have a professor who is collaborating with various different doctors to actually look at nebulizers, which is the tool used for bringing medication down into the lung. These nebulizers were developed primarily for adults and not for children. And if you have a young child with asthma or other kind of medical conditions, this professor is actually doing research on how you would modify those nebulizers to actually bring the medication to a physically smaller lung, and the breathing behavior of a infant is very different from an adult as well. We have a world-class electronics manufacturing facility. That's an area that I do my research in. Any electronic product, your cell phone, your television set, your refrigerator, anything that has a circuit board in it goes through a manufacturing process called surface mount technology assembly. And we actually have a multi-million-dollar surface mount electronics manufacturing line here at RIT. We collaborate with a lot of different companies to do research in something called miniaturization, really taking our existing products and trying to make them smaller and smaller and smaller, which becomes a challenge for even these sophisticated tools. And then we have a number of different professors who do research in robotics. We even have a new professor who's doing some research in autonomous cars. You can do research specifically on a particular robot, or even the systems integration of how robots are utilized in industry for manufacturing purposes or what have you. Integrating automation, PLC programming with 6-axis robots to provide a solution for a manufacturing process using robotics and automation. Next slide. So this is a list of professors on our left side that do various different types of research in the key areas that I mentioned earlier. We also have lots of professors on campus that you may take elective courses with that have supported our students, even in other departments across campus. So that's a short list of other professors that have supported our graduate students across campus. There's a little graphic here on finding a capstone. Students sometimes have a difficult time finding an advisor for doing research. And really the best methodology for finding a professor is being open-minded, understanding all the different areas that our professors on the left-hand side there do their research in, finding someone that you have a similar interest in, and then working with them to achieve the objective of doing your proposal and doing your defense. Just a few slides here on some student capstones that were done in the past, some ASTM methodology, research. On the lower right, we actually had a student who worked for the company Cummins and did a presentation for his capstone on some work that they did at that company. In the upper right-hand corner, we have students that even do more material science for thesis research. And then in the lower left is my electronics manufacturing line there. That lots of students do that option, and there's lots and lots of jobs available in the electronics manufacturing industry. It's a global industry. Every city around the world has many companies that do this type of manufacturing process. Next slide. I already mentioned the difference between thesis and capstone. So I'll skip this in the interest of time for now. So this is a slide on OPT, which is also related to your co-op experience here. If you're an international student, you're able to do OPT for I'm thinking of CPT. I may be talking incorrectly here. You have CPT and OPT, which is your ability to go and work at various different companies, either as a student or after you graduate. Okay, let's go to the next slide. All right, I think that's the end of my presentation.
Great, thank you, Martin. There is one question from one of our guests, and I'll read the whole thing to you so you can get the background.
Sure.
In India, a majority of the mechanical engineering graduates are interested to get into research and development, but due to lack of opportunities, they have to get into manufacturing and servicing even after being proficient in SolidWorks, CATIA, or AutoCAD. Does the MMSI program equip students to get into R&D roles?
Yes, absolutely. A lot of our core classes, as well as those option courses, take you in a much deeper depth of understanding than what you may have gotten as an undergrad. And many of our students actually work for that list of companies I showed to you earlier that are more research and development than just manufacturing. There's lots of opportunities in the area of manufacturing, but those aren't the only types of jobs that you'd be, have the skills to apply for. And really, that's another real value of the co-op program. I'll say one thing on that question about co-op. You have a year that you can go on co-op as an international student. I think it's like 364 days. Many of our students will do one company placement for 4 to 6 months, right? They'll get a feel for that particular job. Maybe they end up, based upon what's available to them, being more in a manufacturing role. But then they will say, I'm done with that. I'm going to come back to RIT, take a few more classes, and then go off to another company, and then have another opportunity to find more of an R&D role. And then you'll have both those types of experiences on your transcript and on your resume. And then hopefully both those companies may be in a position to offer you a job, or then you could take those skills and go look for a specific R&D position. So the type of education you get here at RIT will prepare you for finding those types of jobs.
Great, thank you, Martin.
Yep.
Thank you.
Excellent. Thanks, Martin. We looked at the schedule here and we have a little bit more time. So I do want to share a few slides just kind of about RIT as a whole in our campus life here. Can everybody see my screen?
Yep.
Okay, great. And as always, please put any questions that you have in the Q&A or in the chat. So I'm just going to go through here. Frequently when I'm on the road engaging with students, they'll always say, where are you? And I'll say, I'm in New York. And they'll go, oh, New York City. Though I love New York City and actually it's where I'm from, we're in the other part of the state, much closer to Toronto than New York City. We're kind of a small to medium-sized city. It's very safe. Originally, RIT was in downtown Rochester, but about 60 years ago, we moved out to the suburbs, into a suburb called Henrietta. We have this gorgeous 1,300-acre campus that's kind of a small city unto itself, very safe and very scenic. And here are some pictures of life on campus. There's a lot to do. There you can see kind of our climbing gym on the right. You can see some students in one of my favorite parts of campus called the Global Village in the middle. And we're very proud of our campus. We've had significant facility upgrades and new buildings done in the last few months. The biggest of those is what's called our shed, the Student Hall for Exploration and Development, just opened this fall, and it was over $130 million project. So gorgeous new building. We also have our Campus for Center Life. And as it relates to all of our students, we have over 300 clubs. So lots of different ways to get involved. Sometimes I won't do it today, but sometimes when I'm in front of an audience, I will read out all of the clubs that start with the letter B, and that typically takes me 90 seconds to get through them all. So I'm not going to do that today, but there's one that's the Beekeepers Club. Another very active club for our friends from the Indian subcontinent is Oasis. They are our Indian student union, and they get together frequently. They have celebrations around all the various holidays. and a lot of networking opportunities. But there's a little of something for everybody here at RIT in terms of campus and ways to get involved. We pride ourselves on being a very diverse campus. We have students from over 100 countries and literally from all over the world, and that's spread throughout our colleges. So we, really want students through Futurense to come here and, bring your best you, so we can learn from you, we can celebrate your experience, and you can get a chance to interact with not only American students, but students from all over the world. And finally, I know there's a lot of questions about student visas and I-20s. And I know that for students, it can be a very, what seems like a complicated process. In a lot of ways, it's not. And we've really done our best to simplify the process as best as we can for you. And here we have a QR code you can scan where you can get more information. But we also work really closely with Futurense to help you understand the documents that you need to get in. And so we can get an I-20 turned around to you as quickly as possible. It is slowly becoming easier to get a visa for students from India than it was at the height of the pandemic. But the more time you can give yourself, the better. And so the best thing that you can do if you're concerned about a visa is to go through the application process. First make sure you're admitted and make sure that this is something that you're interested in. But the sooner you can get that process going, the better. We are a very welcoming and wonderful place to study. We have a long, long legacy with India, and we would love to have you be that next part of it. And with that said, I'm going to stop sharing my screen and open the floor to some questions. Are there any other questions from the audience?
Sure, Paul. So a couple of questions that I've received. One is about on-campus housing. If you could guide us a bit about that.
Absolutely. And we will get a document that will be helpful for your end, Raghav. Now, most of our graduate students choose to live off campus. And when I say off campus, we have several apartment complexes that are adjacent to campus, and a number of them have either get picked up by the RIT shuttle or the apartment complex has a free shuttle. So just because it's off campus doesn't mean it's far away. If there is a graduate student who definitely wants to live on campus, we can explore options with you. And the first part of that process is completing a housing contract. But we've been very fortunate in that recently a brand new apartment complex has opened very close to campus. And that's increased the supply of graduate housing. So, we will have a housing webinar that if you are admitted and you decide to enroll, will be a way that you can get more information. But please know that there are a lot of options available, and we're here to help you get situated and find the best housing for you.
Perfect. And Paul, one final question that's about on-campus jobs. So are there like part-time jobs that they can do, and what is the average pay for those jobs?
Absolutely. Thank you, Raghav. So first, all international students are eligible to work for up to 20 hours per week. It is very, very easy to find a job on campus. In fact, we have more jobs than students who actually want them. So there are always openings. So students aren't competing for jobs on campus, they're competing for the quality of jobs.
Right.
And, a lot of students want something where, maybe they can get some studying done on the side, or, it's not overly tiring. But if you need a job, we can get one for you. Typically, they pay anywhere from $16 to $19 per hour, $15 to $19 per hour. There's a range in there. But they're very easy to get, and you can typically, if it's important to you, you can begin working in the first or second week that you're here on campus if you do some footwork ahead of time.
Perfect. I think, guys, this was superb. I think we covered every possible thing. Thank you so much for being so articulate, and I think this would be a very, very big motivating kind of video for the audience that wants to be a part of the RIT.
Excellent. And for the students still on, I would like to thank all of the faculty and staff from our College of Engineering Technology who joined us today, and giving you a lot of really good information about the program and the difference it makes. I also want to thank my colleague, Paula Pena, for her time in getting everybody together and organizing this presentation. And I'm seeing Mike has come off camera. Do you want me to pass it over to you to wrap it up here, Mike?
No, I just wanted to say thank you to all of our guests, and we hope you enjoyed the presentation. Please feel free to reach out to any of us with any questions that you have, and we look forward to seeing you on campus.
Thanks for joining us, everybody.
I hope this was helpful, guys. I tried my very best to ask all the questions I thought were relevant to you. But if you still have doubts, if you still think you're very interested in building a career in the US, pursuing your master's from a top US university, have more doubts, definitely reach out to us. Definitely book a one-on-one counseling, free counseling with our counselors, our in-house experts, to try and understand what are your chances, what are your prospects of doing the master's from a top US university using the Futurense US pathway and build a high earning career in the US. See you.